Hi guys, we are going to take a look and I'm going to walk you through some things on scientific notation. I hope that this helped you out with the scientific notation practice that you can find on Teams. So yeah, we're going to take a look at some of the basics and then I'm going to show you also how to use your calculator. This is going to be critical for this year in AP Chem. And this is the type of calculator that I have available in my classroom. You might be familiar with it from your honors chem class. And I highly recommend that you get one of these. The more you know your calculator, the better you are going to be in AP Chemistry and the smoother the year is going to go. We don't know how the year is going to play out yet because we're dealing with this whole COVID-19 thing. So, having your own calculator at home would be really critical. So that's my thing about calculators. And this is the one, I've been using this thing since 8th grade and it works and it's got everything you need. Now, if you have a graphing calculator because you're taking calculus, you're going to find the same basic functions on those because they're a Texas Instruments calculator. What I highly suggest though is do not buy a Casio calculator. A lot of those are not necessarily scientific calculators, they're engineering calculators, and they have some settings that we don't need, a lot of them, and they have things that are missing, so you'll end up with issues all year long. So there's that. Okay, let's get into a little bit on scientific notation. So hopefully you were able to read through the intro information and kind of get an idea of what scientific notation was about. You might have looked at this in a math class or another science class before, so this is mostly, hopefully, some review, but let's talk about it a little bit. So in general, scientific notation gives you some sort of number. Let's try like 1.2. And then it has this part where it says times 10 and then gives you an exponent. That exponent can be positive or negative. And what this really means is this is basically a math problem. We've got 1.2, we're multiplying it by 10 to the third power. Well, let's do that math. If we had 1.2 times 10 to the third power is 10 times 10 times 10. Well, every time we multiply 10 by itself, we add another 0. So if we've got 10 to the third, that's basically 3 zeros. So it's 1,000. Well, if we were to take this and multiply it out, anytime you're multiplying by something like 10 or 100 or 1,000, you're essentially just moving the decimal over however many times there are zeros. So there's 3 zeros there. So I would move my decimal in 1.2, 1, 2, 3 times. Throw in some zeros and take my decimal out. So really what this number is, this 1.2 times 10 to the third, is really 1,200. So it's not some crazy number. It is exactly the same as any other number. So if we were doing math with this, we're going to approach it the same way. We just might type it into our calculator different, but it's still just a number. Now, why do we use scientific notation? Well, let's try a different number. If we had something larger, so say we had 1.2, but we're dealing with the number of atoms in a, graduated cylinder, number of atoms, or say number of molecules of water. So maybe we have this to the 24th power. That means we're taking this 1.2 and multiplying it by not 100 or 1,000 or 10 or anything easy. It's a 1 with 24 zeros after it. And I don't know about you, but I don't want to write all the zeros. And I don't want to write that number out. So instead of doing that, ooh, that's smeary. Fun. Taking my eraser. We're going to write it in scientific notation to make our lives easier. And yes, we do have numbers that are that big. A famous one is called Avogadro's number, and it is 6.022 times 10 to the 23rd. And that's the number of atoms or molecules or electrons or something in 1 mole of something. So we're going to use the idea of the mole a lot. We will convert using this number sometimes. So we do have things with these huge exponents, and we don't want to deal with those exponents and have to write, or we don't want to deal with all those zeros, because the likelihood that you mess up that calculation because you didn't type in enough zeros into your calculator is way too easy to mess up. So we're going to simplify things and use scientific notation. All right, so let's talk about a little bit of what a negative does to this. Okay, I'm gonna leave this on here so you guys can see it. Ooh. All right, had to make up a whiteboard because I'm at home here, guys. All right, so let's say that we took this same 1.2, multiply it by 10 to the negative 4th power. Well, a positive number, 10 to the 3rd power, means it's 10 times 10 times 10. Well, if we're raising it to a negative power, that really means we're dividing. So it's like 10 divided by 10 divided by 10 divided by 10. So we keep dividing. Well, what that does is it makes our number smaller, right? So instead of moving our decimal to the right to make it a big number, we're going to move it to the left. So if we had a 1.2 and we wanted to multiply this out, we want to move it to the negative 4th power. We're going to move it 4 times to the left. I hope this is the right direction for you. This whole video camera thing is new to me. So we're going to move it 4 times. 1, 2, 3, 4. So there's our new decimal, and we fill in the spaces with zeros. So this is really 0.00012, and I like to throw the 0 out in front and trap my 0 or my decimal in its place so it doesn't move. So that's the same number. This 1.2 times 10 to the negative 4 is the same as that. Now again, why do we want to use this? Well, I could type this in my calculator, right? Well, what if you were dealing with a really small value, like the diameter of an electron? Well, this might be 10 to the negative, 20th or something like that. So we're going to end up with really tiny numbers, lots of zeros. Again, way too easy to mess up. So we want to use that scientific notation to make sure we're putting in our numbers correctly into our calculator and doing our calculations correct. Alright, so now we're going to take a look at how do we actually put these numbers in scientific notation into our calculator and type them in correctly. So you do have the directions on your sheets. They're right here. So you can check out that and kind of look through the steps. And I'm going to basically walk you through the steps right now. So we're going to start with, we have our calculator on. We're going to start with this number up here at the top, okay? That same number. So right now, you'll notice on my screen, hopefully, that it has just this little degree thing right there, nothing else listed. I'm going to show you how to change it into scientific notation so that your answer appears like this, like these numbers. But for now, I just want to check these numbers. Like, is 1.2 times 10 to the 3rd really 1200, or am I lying to you? So let's try it. Okay, so I want to type this number in to my calculator, and I want to tell my calculator that it is scientific notation. Now, what a lot of students want to do is they want to write 1.2, they want to hit times, and then 10, and then go from there. The problem with that is that now this is a math problem that your calculator is trying to do order of operations on, right? It doesn't know that you're putting scientific notation in, so it doesn't know to keep that whole thing together as one value, okay? So if I put in this times another thing or adding it to another thing, it's going to do all the order of operations like it's been taught to and not say, oh, well, I need to keep this together because it's scientific notation and it's all one number. So you've really got to think about, what are we actually entering? So I'm going to clear that out. What do we want? We're going to use a special button to represent this part right here. So the only numbers we're typing is this 1.2 and this 3. What's going to take the place of this part is the symbol EE. So you might take a second and try and find that on your calculator. But where you'll find it is right here. So not this button, x to the -1, but right above it, written on the calculator itself. So how do we use that? Okay, well, if I wanted to type in this number, I'd start with my 1.2, put that in. Now, I want that EE, so I'm going to hit second, because it's in yellow on my calculator, and then I'm going to hit that button. Right, we're going to use that function. So now it says E. Well, that E takes the place of the times 10, so we don't have to put times in, we don't have to put in anything extra, we just put it in E. And then we need the 3, so we hit 3. Okay? So this is taking the place, but the times 10, we use that EE to replace it. Okay? And on your screen, it should say 1.2 E3. And hit enter. Guess what? It's 1200. Because I wasn't lying to you guys. I was telling the truth. So we know that this number is equal to 1200. Okay, let's check our other one. So we'll try it again. 1.2, second, there's our E. Now I want -4. Well, on this calculator, my negative is down here. I hit that first, and then 4. Ooh, I didn't actually hit it. There we go. And that's our exponent in. Now I can hit enter. And look, 0.00012. Same as what we got here. So this is an easy way of taking a number in scientific notation and getting what it actually truly means, right? Now, let's try it with one of those I talked about. So say it was 1.2, I did my E, and then I had one of those huge numbers, like I raise it to the 23rd power because we're dealing with, you know, the number of water molecules in a graduated cylinder. And I hit enter. It spits it back out in scientific notation. And it does that because the calculator literally cannot put 23 decimal places after that one, or 23 places. It doesn't have the capability of doing that. So it automatically puts in scientific notation. So when a number is way too big or way too small, so say it's something small like 1.2 times 10 to the -22nd. Again, it's going to put it in scientific notation because it can't handle it. Now, that's how we type in our numbers. We're just going to always type that, use that E for that times 10. And again, if we try to use, we try to put times and then 10 and all that, it's going to mess it up. And I will show you guys an example of that. So, we also want to be able to do math with this. So I'll show you how to do that, and maybe multiply or divide some numbers, add them, that kind of thing. But if you want your answer to pop out in scientific notation, so say I want to put in any random number and I want it to tell me it in scientific notation, we can have our calculator do that too. So you'll notice over here there's a second button, and then there's this one. Up above it says SCI/ENG, so that means science and engineering. So this is a scientific calculator, and it can do scientific notation. So if you hit second, and then you hit that button, you get a menu. So flow or FLO just means the normal mode. So it goes with the flow is what I was saying. But I want it to be in scientific notation. So I'm going to hit go over with my little arrow button to science, and then I'm going to hit enter. So now, no matter what I type in and no matter what calculation I do, my answer is going to appear in scientific notation. So let's take a look at what that might look like. So say I took this 1.2, I'm typing my number in scientific notation, so I'm going to put E, I'm going to put that third. And I want to add to that number 100. So just the number 100. I'm going to put that in. And I'm going to hit enter. Now let's think about this. If I was to take this 1200, which is what that number really is, and add 100 to it, I should get 1300. Well, I haven't really changed where my decimal would be. I haven't really changed any of the places of the numbers. So we can predict this should say, as my answer, it should say 1.3 times 10 to the third. So I'm going to enter 1.3 times 10 to the third. And it does say 10 to the 03. That 0 is there just as like a placeholder because that the calculator has to display something there. We don't have to write the 0 there. So we can predict our answer. But let's say we, instead of wanting to add 100, maybe we want to multiply by 100. Okay, or let's multiply by 10. Let's do something easy. So remember when I said when we multiply by tens or hundreds or thousands, it's really moving the decimal. Well, this should move our decimal one place. This should change our exponent if we multiply by 10. So you can always go back to the previous thing you did, by the way, by going up, and then you can just edit what we did. So this time we want to multiply, and then I want to multiply by just 10. So really, just like I multiplied by 1,000, now I'm multiplying by one more decimal, right? I hit it. Oh, what did I do? Oh, I have an add in there too. There we go. Times 10. And I hit enter. And now I have 1.2 times 10 to the 4th power. Because I multiplied by another 10. I've multiplied, instead of by 3 zeros, by 4. Or by 3 tens, I've multiplied by 4 tens. Multiplied it again. So it kind of gives you an idea how these numbers work a little more. Okay, so let's go back up here. What if I wanted to divide it by 10? So we have 1.2 times 10 to the third. Think about what you think that might do to our number. Make a little prediction for yourself. Alright, so let's hit enter. 1.2 times 10 to the 2nd power. Okay, well, let's think about what we're doing here. We've got 1.2 times 10 to the third, so we're timesing by 1,000, and then we're dividing by 10. So one of our zeros cancels. So we're really only multiplying by 100. So this is kind of how these numbers work. Now, what if I wanted both of my numbers to be in scientific notation? Well, that's fine. Let's do this. Let's do 1 times 10 to the third. So keep that same number. So I hit that my E to get my times 10. Now I want to divide it by 4 times 10 to the 5th. Okay? So I'm going to write that down just so we have this thing, because I'm going to show you guys what happens when we don't put it in scientific notation. Not good things. Okay, so we're doing 1.2 times 10 to the third. We're dividing it by 4 times 10 to the 5th. So 4e5. Alright, we want to know what that equals. So we're going to hit enter, and it's going to pop it out in scientific notation. We get 3 times 10 to the negative third. Alright, well, let's kind of think about what this means. We've really got 1,200, 4 times 10 to the 5th power. So that's 4, and we're moving the decimal 5 places. So we're really adding 5 zeros to it. Okay, so 1,200 divided by 400,000. So that's why we get this number. 3 times 10 to the negative third, 1, 2, 3, is 0.003. We're getting a decimal. Right? We've got a smaller number divided by a larger number. We're going to get a decimal. Alright. So these are the same two math problems. Could I have written it like this? Yes. But is it easy to forget a 0 and then mess up this answer? Yes. And that's why we use our scientific notation. Okay, I'm going to show you what happens if we don't put it in our calculator properly. So this is our answer that we got. We like this answer, right? Same answer down here. Okay, now, a lot of students want to type it in like this. They want to go 1.2 times 10 to the 3rd power. And then they want to divide by 4 times 10 to the 5th power. And you hit enter. Now our calculator says 3 times 10 to the 7th. It's telling us that we have 3, 4, 5, 6, 7. That our answer is 30 million. that when you divide 1,200 by 400,000 that you're going to get 30 million. And that doesn't make any sense, because if you have a small number divided by a bigger number, you should get a decimal, not 30 million. Okay? So that is why you have to put it in using that E button. Okay? You will get the wrong answer, because now your calculator is not doing order of operations right. You know what it's doing? It's taking this 1.2 and timesing by 10 to the third, and then it divides by the 4, and takes that answer and multiplies it by 10 to the fifth, and then you get all these extra zeros. No one wants that. Okay? So, we have to put it in correctly. Alright, let's do one more. I'll do one from the assignment. I'll do the first one. So we got 4.53. So this is on second page, number 21. Times 10 to the fifth. So I put in my first number. I want to add. And I want 2.2 times 10. There's my E. To the 6th power. Okay? So I'm doing something to the 5th power and something to the 6th power. So that means they're off from each other by 1 decimal place. Okay? Oh, and I think oh no, I didn't. Okay. And I hit enter. I get 2.653 times 10 to the 6th. Okay? We're adding these two things, right? We should have probably the one that's bigger. Should match our exponent there. And so that's going to be our answer. We want our answers on this part in scientific notation. I don't want to write, 2653000. I don't want you to write all that. I want it in scientific notation so we get used to it. So, putting it in our calculator, what's different is how we type in the number, but it's how we do the operations, the adding, multiplying, dividing, all of that is not different. Okay? It's the same calculations. So we can subtract any of them that have, any of them that are in parentheses like this, we're multiplying between them. Any with a slash, we're dividing. So yeah, you can start to see how the work there. And this will get you really used to using your calculator. On the first page, and it continues on the second page, what we can do is have our calculator in scientific notation, and we're just practicing putting in some numbers and seeing how they look in scientific notation. So this one, 5.280, the decimal is already in the correct spot for scientific notation, right? Everything has the decimal after the first digit. So this one's already in that. So it's 10 to the 0 power. So if we put 10 to the 0, that's still scientific notation. We're just not multiplying by anything, because 10 to the 0 is 1. If we did number 2 and we put in 2,000, it's going to pop out with 2 times 10 to the 3rd, because that's 2 times 1,000. So it's just going to show you what these look like in scientific notation. So make sure you're counting those zeros. I did put commas in the numbers to help you out with making sure you got the right number of zeros to convert it. You can also do it like this if you want to just move the decimal. Remember, your decimal always needs to end up after the first digit that's not 0. You get rid of all the extra zeros. So we're trying to get to the first real digit and then a decimal. Okay, you can't have 2 digits out in front of your decimal. You can't have 3. Your decimal can't be in front of that digit. You gotta move it after that first digit. Okay? So hopefully this got you guys a little bit of exposure, gave you a little information on your calculator. Start learning your calculator, using it. It's going to become your best friend. Alright? And remember, the last thing, if you need to change out of scientific notation, you want to change back, just hit second, that science button, and just go back to low and hit enter. And now it's in normal notation. So also, if you had a number that was in regular, you could go ahead and go to science and it'll convert it for you. So if you have an answer that's in regular notation and you need it to be in scientific, you can just switch the mode and it'll do it for you. Alright, I hope that's helped you guys, and contact me if you have any questions. Have a great day.